reaction. The word redox means a reaction where reduction and oxidation takes place simultaneously. As you very well know, reduction means gain of electrons and oxidation means loss of electrons. If we can somehow devise a process where oxidation is happening at one end where the electrons are being lost, while reduction is happening on the other end where electrons are being gained. Hence, I would come under the situation where the electrons are lost from one end, gained at the other end. Hence, I end up in a transfer of electron which is nothing but opposite to the flow of current. So, we have generated current in that case. That is, electrical energy is derived from a redox reaction, but the redox reaction should be spontaneous. The word spontaneous means that the process should happen on its own. The Gibbs free energy, if you are aware of it, the Gibbs free energy for the process should be negative. The cell is nothing but a device which converts your chemical energy into electrical energy via a redox reaction which happens on its own. Have a look at the device which we use. How is the construction of the cell done? The cell has got two half cells. Together they make a full cell. One half cell has a metal rod and a solution of the metal salt, while the other half cell also has a metal rod with a salt solution of the same metal. In this particular galvanic cell, we are taking into account the zinc rod dipped into a zinc sulfate solution, a copper rod dipped into a copper sulfate solution. The zinc rod is dipped into a 1 molar zinc sulfate solution. We have deliberately taken it to be 1 molar so that the conditions are standardized. I am talking about the concentration should be 1 m. The temperature is 25 degrees C or 298 Kelvin, while the pressure is 1 bar are the conditions that we use. So we have the two cells constructed, and then they are also connected through a wire on the outside with the voltmeter connected to tell us the voltage in the cell. In the center of the two half cells, you can see they are connected by a U-tube like a thing known as the salt bridge. The word bridge means it's connecting the two half cells, and the word salt means there's some salt in it. We very well know zinc is more reactive than copper. Since zinc is more reactive than copper, it's understandable that zinc will easily lose electrons if it does so. You have lost electrons at the zinc electrode. The zinc metal oozes out from here, goes into the solution as zinc ions, and the 2 electrons are left here. It is because of these 2 electrons that this particular electrode is a negative terminal. So wherever oxidation is happening, there is loss of electrons, and this loss of electrons makes the electrode negatively charged. Hence, the left hand side of my cell would have anodic side as the negative terminal. These 2 electrons then move towards the other half cell. Since the electrons are moving towards the other half cell, it's understandable that the other half cell metal should have a positive charge in comparison to this metal. Only then can the electrons move on this side. In comparison to zinc, the copper metal is less reactive. Since it is less reactive, it can accept electrons. As compared to zinc, its tendency to accept electrons would be stronger. So, the electrons are moving from the left side towards the right side, towards the copper metal. At this particular half cell, you have got 3 things. You have a copper metal, you have copper 2 ions from the solution, and you are supplying electrons. And it is understandable that out of the 2, if the electrons are to be accepted, they have to be accepted by the positively charged ions. That is exactly what happens here. The positively charged ion, copper, accepts the 2 electrons coming from the external circuit and become copper solid. So you get a deposition here. While in this case, there is loss of the metal because zinc will continuously move out as zinc ions, while on this side, we will have deposition of copper and this would start to thicken over a period of time. What is the purpose of the salt bridge then? Firstly, it is connecting the two half cells. You cannot have a cell or a circuit complete if there is no connection between the two half cells. So you require a salt bridge. This salt bridge has got salt in it. What is the purpose of the salt? As I just said, in this solution, initially we had zinc sulfate, where zinc ions were neutralized by the sulfate ions, the positive and the negative charges. While the reaction starts, we are generating more number of zinc ions into the solution. If zinc ions are increasing, this particular solution will develop a positive charge. And to neutralize this positive charge, we have the chloride ions moving towards this half cell to neutralize the zinc ions which are generated. So you'll have to continuously, the salt bridge is continuously providing chloride ions to the salt solution here to neutralize the positive charge which is accumulated on this half cell. Fine? Moving on to the other half cell, what's happening there? Here you have the copper ions from the solution are moving onto the metal. Since the copper ions from the solution are moving onto the metal, the solution here would now have excess of sulfate ions. The copper ions are being used up. Since you've got sulfate ions in excess, this solution will definitely become negatively charged. And to prevent that negatively charged solution, this negative charge to get accumulated, you require ions. These ions would be the positively charged ions. So, from the salt, the potassium ions move towards the right side where the reduction is happening. So, what we have concluded right now is that in a galvanic cell, you have got two half cells. Left-hand side half cell is generally taken to be the half cell where oxidation takes place, where oxidation is loss of electrons. This oxidation leads to loss of electrons and these electrons then move from the external circuit towards the other half cell. So, the electrons are moving from this half cell to this. Wherever oxidation happens, it is always the anode irrespective of the type of cell. Oxidation is always at the anode. Since the electrons are moving from the anode towards a site where reduction is happening and reduction always happens at the cathode. So, your electrons are moving from the anode to the cathode and I hope you know it very well that if the electrons are moving from the anode to the cathode, then the electric current is moving in the opposite direction. The opposite direction meaning the electricity, the current flow would be from the cathode towards the anode. Moving ahead, what was the function of the salt bridge? Let me give you a recap of what is exactly the function of the salt bridge. Firstly, it connects the two half cells, so makes your circuit complete. Secondly, prevents accumulation of the charge. What do I mean by this accumulation of the charge? Let me recall, in the last slide, we had zinc ions generated here, so we had a positively charged accumulation on this electrode. Whereas copper ions were used up here, sulfate ions were excess, so we had a negative charge accumulation on this half cell. That is what we are talking about. There is a positive charge accumulation in the anodic half cell, the half cell where anode, the oxidation that is, oxidation was happening is called as the anodic half cell. So there was positive charge there and this positive charge was neutralized by the chloride ions from the salt bridge. While the negative charge was accumulated on the cathodic half cell and this negative charge was counteracted by the positively charged ions from the salt bridge. Your salt bridge was having potassium chloride in it. Positively charged potassium ions, negatively charged chloride ions. So the positive charge in the anodic half cell was prevented by the chloride ions and the negative charge in the cathodic half cell was prevented by the potassium ions from the salt bridge. So over a period of time, your salt bridge will get used up. There might be a need to reintroduce another salt bridge. On top of it, the other observation that you should be aware of is Over a period of time, these ions will get saturated, your solution will get used up, plus the zinc electrode will start to thin down because of the zinc ion moving out. Whereas the copper electrode will start thickening up due to the copper ions from the solution getting deposited. Moving ahead, let us revamp the points to remember. That is my way of learning. If you can learn the word lone. In the word lone, there is a deep meaning for the galvanic cell only. Lone, L, stands for the loss of electrons, which always happens on the left side of the galvanic cell. Loss of electrons is also called as O for oxidation, which always would happen at the anode. This is true for all cells in the world. Oxidation always happens at the anode, while N stands for the negative terminal. Wherever there is oxidation happening, there would be loss of electrons, and this loss of electrons causes the negative charge onto the terminal. So if you are aware of the word lone, the galvanic cell is done. So loss of electrons always on the left, O for oxidation, A for anode, and N for the negative terminal. As we just did, the electrons were moving from the anode to the cathode. So the current would be in the opposite direction, from the cathode to the anode. I hope that's clear. The cell representation. How do you represent this kind of a cell without actually drawing those beakers and the actual diagram? The shortcut way of representing the cell is like this, where the cell where oxidation takes place is always taken on the left-hand side, whereas the cell where reduction takes place is always taken on the right-hand side. As we very well know, our oxidation cell contained zinc and the reduction cell contained copper. This double line is important. It refers to the salt bridge. On the left-hand side of the salt bridge, extreme left, you have the metal which is undergoing the oxidation. On the extreme right is the metal which is acting as the cathode. The salt bridge was in contact with the two ions in the two half cells. So your salt bridge is actually in contact with zinc ions on the left and copper ions on the right. We have deliberately written a concentration of 1 molar because we are still referring to a standard cell. That is how you represent the cell. By looking at the representation, you can know which is the oxidation half cell, that's the anode, and which is the cathode. Where would the oxidation take place? This side. Where would the reduction take place? This side. Moving ahead. Now to gather all what we've just done with the help of this question. If you are given a cell representation, in the given cell representation, you have a half cell which is cadmium in contact with cadmium ions, 1 molar, a standard cell. Silver in contact with silver, silver ions in contact with silver metal, which is again 1 molar, and you have the salt bridge in center. As you know, this side is your left-hand side. Since it is the left-hand side, therefore it is the anode. Since it's the anode, we will have the oxidation taking place here. Since oxidation takes place here, this is the negative terminal. The first question, you need to identify the negative electrode. So the answer becomes cadmium, because cadmium is where oxidation is happening. The cathode. Cathode is where reduction happens and it is always on the right. So your cathode is silver metal. The metal ion which is undergoing reduction. Reduction happens on the right. Which is the ion on the right? Silver ions. So the metal ion undergoing reduction becomes silver. Give the reaction at the anode. If I talk about the reaction at the anode you had cadmium ions. So in this case, since it's oxidation, your cadmium would transform into cadmium ions plus 2 electrons, the loss of electrons, that's oxidation. At the cathode, you have silver ions undergoing reduction, that is gain of electrons, to become silver. Now, when you write the net reaction, you do not want the electrons in it. So, you need to add the 2. Before adding the 2, you need to cancel out the electrons. For that, you need to multiply this by 2 so that the electrons get cancelled. If the electrons get cancelled, your final reaction becomes cadmium, no change, 2 times silver ions because you've multiplied it by 2, cadmium ions, no change, and silver. That is how you approach such a problem. Lastly, one more question on the concept. If you are given a cell reaction, how do you go about it then? In that case, you first need to identify what is the information given through the reaction. Magnesium, as you can see, is transformed into magnesium ions. There is loss of 2 electrons. Since there is loss of 2 electrons, this is oxidation. And if this is oxidation, it is happening at the anode. And this would be the negative terminal. I recall, I told you to remember the word lone, L-O-A-N. Oxidation at the anode, the negative terminal. So, your negative electrode in this case would be the anode. Hence, the negative electrode becomes magnesium. The metal acting as the cathode is where reduction is happening. So if magnesium is acting as the anode, it's understandable that silver will act as the cathode. Metal ion undergoing reduction. Reduction happens on the cathode. Cathode is silver. So the metal ion undergoing reduction would be silver. Metal ion undergoing oxidation. The metal ion undergoing oxidation would be, it won't be a metal ion. There's a wrong framing of the question. The metal undergoing oxidation would be magnesium. Give the reaction at the anode. At the anode, the reaction would be magnesium changing into magnesium ions plus 2 electrons, whereas at the cathode, the reaction would be silver ions accepting an electron to become silver. Before I actually add to get the net reaction, which you don't require in the question, but if you were asked so, then you need to multiply this by 2 and then add the 2 given equations. The cell representation for the given cell can be done here. If I talk about the cell representation, you have the anode on the left, so you have magnesium in contact with magnesium ions. You have a salt bridge. The cathodic half cell consists of silver ions in contact with silver metal. You may mention the physical states. You may mention the concentration. That's up to you. How informative can you make the cell representation? With this, I close my class. Thank you once again.
Today we will talk about algebraic expressions.
reaction. The word redox means a reaction where reduction and oxidation takes place simultaneously. As you very well